This paper discussed a coupled elastoplastic damage model for brittle rocks. Background: China is one of the few countries in the world that use coal as an important power source. More than 70% of its total power generation is thermal power. However, coal mine accidents have become a major obstacle to its development. Coal mine accidents are mainly included in the fields of gas burst, roof fall, rock burst, and so on. Therefore, the constitutive relation and damage model of brittle rock is still a major issue to be solved urgently. This article proposes a coupled elastoplastic damage model in order to discuss the plastic deformation and induced damage found in brittle geomaterials. Micromechanic considerations determine the effective elastic properties of anisotropic damaged geomaterials. An energy-based damage criterion is used to deduce the damage initiation and the damage evolution law of the brittle rocks. Moreover, the nonlinear unified strength criterion is modified. It takes anisotropic damage and the effects of intermediate principal stress into account, in order to determine both the yield and plastic potential functions. The non-associated plastic flow rule is utilized. The consistency condition of plastic and damage is applied in the coupled process. The damage evolution rule and the coupled plastic damage of brittle rock are conceived within the framework of irreversible thermodynamics. By comparing the simulations and the experimental data from limestone that was subjected to various loading paths, a strong connection between the numerical simulations and experimental data is therefore obtained. The numerical results show that the new model is able to describe the main features of the mechanical properties observed in brittle rock. Conclusion: a coupled elastoplastic damage model that addresses the coupled elastoplastic damage is proposed. The model can be used to describe anisotropic damage behaviors, elastoplastic deformation, pressure sensitivity, plastic compressibility and dilatancy, the degradation of elastic properties, and coupling between the plastic flow and damage of semi-brittle geomaterials in triaxial and uniaxial compressive tests.